Good afternoon. Today is lesson 18, and we actually have two things that we're going to be looking at, and the first is multiplying three digits, which is very much like multiplying with two digits, just adding an extra digit in there. Multiplying three digits and multiplying with missing factors. Multiplying with missing factors. Again, two concepts, but pretty easy once you take a look at them. So we'll jump right in with multiplying with three digits. So let's just take a look first of all. If we were to say 3 times 2, you know that order doesn't matter. 3 times 2 equals 6. 2 times 3 equals 6. The commutative property says order doesn't matter. Now when we multiply by by 3 digits, and that's where the 5 came in, and we say 3 times 2 times 5, well, we can group them together any way that we'd like because order doesn't matter. I could say 3 times 2 is 6, times 5 equals 30, or I could say 2 times 5 is 10, 3 times 10 equals 30. Because order doesn't matter with multiplication, when I multiply with three digits, all I'm going to recommend to you is that you just look at the one that jumps out as easiest to you. So if you wanted to multiply these two together and then do your third, that'll work. If you want to multiply these two together and do your third, that'll work. Even if you wanted to multiply the first and the last one together and then the middle one, that's fine too. Whatever floats your boat. Order doesn't matter with multiplication. So when you multiply by three digits, multiply 2 and then go ahead and multiply the third. That is the part of the lesson about multiplying with three digits. Now, the next part of the lesson is multiplying with missing factors. Now, you can actually see them a couple of different ways. Sometimes you would see it like W times 3 equals 18. Or you might see it as 3W equals 18. Whenever you see a number and a letter together like that, you always know that it's going to be multiplication. So it doesn't matter how it shows up. When you have a missing factor, you're going to have to figure out what to do with it. Now, there's a couple different choices. First, in this example, we could count by threes till we get to 18. So I would say 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, yay! W equals 6 because 3 times 6 is 18. Now, doing it that way takes forever, especially if it's a bigger number. So, I don't recommend using that. Go ahead and put an X over that one. Now, another option you would have would be using a multiplication chart, and that's where you would go, okay, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, and then you would go, okay, let's go to the 3, and then you would look across and you would see a 3, a 6, a 9, a 12, a 15, and an 18. Oh, look, I go across and there's my 18. And so there's my 3, and I go up right above it, and it's a 6. And so 3 times 6 is 18. Fabulous. But are you going to do a multiplication table just to find your answer, or are you always going to carry a multiplication table? I don't think so. So both of those are terrible ways to find out your answer. Now what we're going to look at is the third way of doing this, and I'm going to show you 2 ways to do it for number 3. Let me just say, some of you will get it right away. Others of you, it's going to be a little tougher for you to see it. That's okay. This is one of those things. Just file it in the back of your head, and you'll remember, and Mr. Burford next year will talk about it even more, but you can just file it away in the back of your head. So let's take a look at the third and better way to solve this problem. So if we had 3W equals 18. Now, the quickest way when it's easy to spot is just know in your head 3 times 6 equals 18. That's the way to do it, is to have it memorized. If you can't, or you don't have it memorized, or it's harder than a one that you would have memorized, here's what you can do. Now again, if you don't fully get it, it's okay. You'll just have to make sure you always have them memorized in this book, but next year this is what Mr. Burford will kind of talk to you about how to do. First of all, we've talked about addition and subtraction are inverse operations. Well, multiplication and division are also inverse operations. So, if I say divided by 3 over here, and I do the same thing on this side. What I do to one side, I do to the other. Well, look, I've got a 3 on the top and the bottom of a fraction, and you know what? I can cancel that out. So I end up with W equals 18 over 3. Well, later on we're going to learn that a fraction is actually a division problem. So what I'm actually looking at here is W equals 18 divided by 3. Well, 3 goes into 18 how many times? And the answer is 6. So W equals 6. Now again, if you don't fully understand the why that works, especially this part right here, don't worry about it. You'll get it a little bit more this year and a whole lot more next year, but just kind of think in your head, division and multiplication are inverse operations, so I can do the opposite. Like when I add, the opposite would be subtract. So that's an easy way to take a look at it. Well, let's take a look at one more, and what if we have a missing factor in the middle of a problem somewhere? So if I have something like 6 times 5 equals 3 times y. Now sometimes they'll put 3y, sometimes they'll put 3 times y. But if I have 6 times 5 equals 3 times y, well, I'm going to solve what I know first. What I know is 6 times 5 equals 30. So 30 equals 3 times y. Now do you see why we don't use the multiplication sign? Because then we have an x and a y in there. And so I'm going to show you what they sometimes do. Instead of putting a multiplication sign like that, they will put a dot. And the dot is also the way of saying multiply. So 30 equals 3 times y. Well, I bet you know in your head, well, 3 times 10 equals 30. That would be correct. But let me show you the long way out. You could just do that. Y equals 10 if you have it memorized. But the next step, which is that, let's always think ahead to what we're going to be doing later in the year. Well, I need to get rid of my 3, so I have my y by myself. So I'm going to divide by 3, since they're opposites, and go over here and divide by 3. And look, voila, my 3 will then be able to be taken out, poof, it goes away. So now I have 30 over 3 equals y, and if you remember, when you see a problem like that, you knew in your head, hopefully, that it was 30 divided by 3 is 10, so y equals 10. So this way right here, when you do it, and you know it just because you've memorized it, for now, that is perfectly fine. This step of going the division and canceling like we did right here, that's called canceling, that'll come later. But it's important that you at least be seeing it a little bit in your head. So when you have a problem like this one, first step is figure out what you know, which would be the 6 times the 5, and then go from there to figure out your missing factor. I hope that makes sense. We'll talk about it more on Monday, so don't really worry about it if you're not quite getting that canceling. But just so it's stored away in the back of your head for later in the year, you'll be doing great. Well, I hope you have a wonderful evening. Made sure I said goodbye this time since I forgot to on the last one. And I will see you in class Monday.